In this video, we're going to be talking about classifying triangles. Throughout the video, you will need to do some algebra on your own. I'll help you set up the algebra in this video, but I'm not going to do it all the way through. You're also going to have to complete some questions just straight up on your own, and you're going to have to check in with me once you're done with the video and you have all of your work completed as a classwork grade. Let's move on. The first way we're going to classify triangles are by angle name. And so our first triangle says, well, what if there are three acute angles? Well, there's only three angles to begin with, but what if all three angles are acute? What do you think we might call that triangle? We're going to go with the obvious name. We're going to call it an acute triangle by angle name. What if it has one obtuse angle, like this angle right here, one obviously obtuse angle? Then we're going to call that triangle obtuse. Now remember, an acute angle by definition is going to be less than 90 degrees and greater than 0 degrees. Obtuse angles is going to be less than 180 degrees and greater than 90 degrees. So we should be able to spot obtuse and acute angles by eye. Then obviously if we have a right angle, we're going to call that a right triangle. And if you have all angles the same, if they're all marked congruent, then we're going to call that equiangular. And that is equiangular. So we got the equiangular, all three are acute, and all of these are acute, so technically when you have an equiangular, you also have an acute triangle. So all equiangular triangles are actually acute, but not all acute are necessarily equiangular. One right angle is a right triangle, and one obtuse angle yields you an obtuse triangle. Those are classifying triangles by angle name. Next, we can classify triangles by their side lengths. So when I look and I see a triangle that has three congruent sides, very similar to the three congruent angles, it's going to be called equilateral. In a football game, if the quarterback throws a pass directly to the side, they usually refer to that as a lateral pass, to the side. Lat refers to sides. So equa, being equal, equals sides. Three congruent sides is an equilateral triangle. And notice we have the three tick marks here denoting that all three sides are the same. That being said, on this triangle we only have two sides that are the same. This triangle we're going to refer to it as isosceles. That's I-S-O-S-C-E-L-E-S. It looks like isosceles. And a reasonable abbreviation would be isosceles, I-S-O-S, period. So we got three sides alike, two sides alike, and then of course no sides alike. If all sides, right, are different, then we're going to call that scalene. So now we have classifying triangles by side name, and down here we have our four classifications by angle name. And now we can put those together. So here is the side names, and then here are the angle names. Now I want to think about every triangle sort of having a first and last name. Side name would be its first names, and angle names would be its last name. So maybe we have an isosceles triangle that has, what if this was a right angle? Then I would call that an isosceles right triangle. What if this was an obtuse angle? Then I could call that isosceles obtuse. What if all the angles were acute? We would call it isosceles acute. Now, it should be known that all equilateral triangles are automatically equiangular. If you have one, you have the other. So if I see this picture with the angles down here, if I see this picture, I know that I can automatically add in this notation. And vice versa, if I start up at the three congruent sides, I automatically know that I have three congruent angles. So equilateral and equiangular always roll together. Now over here, this scalene triangle looks right here like it has an obtuse angle right there, so I would call this scalene obtuse. So every triangle has two side names. Let's try to put this into action. And this is all the information that's new coming at you. Now we're just going to tinker around with these things. So remember, the key is to see, right? The key is to see, and the way I see is to trace. So it says to use the diagram off on the right side, we're going to name the triangle by its side name only. So the first triangle I see is JKM, so I'm going to trace that out. I don't see any tick marks that reference all three sides. I know that this single tick mark is the same as this short piece right here, but that doesn't refer to the triangle that I'm talking about. So because of that, I'm going to go with the name that refers to no congruent sides. So the first triangle is going to be called scalene, or a scalene triangle. Next, I'll trace this one out in blue, triangle KLN. So I'm just going to reuse the diagram. I sort of copied it. I've cheated. Copying the diagram here, and it looks like this side right here is the same as this side right here, but not necessarily this third side. So I have two sides that are congruent. Two sides that are congruent refers to the word isosceles. So triangle JL, or KLN rather, is going to be isosceles. Okay, isosceles triangle. My last one's going to be in green, triangle JKN. So I come here, J to K to N. It looks like all three of these sides are the same, so that is going to be equilateral. Now just if we wanted to take it a step further, this blue triangle KLN over here, it looks like this angle's obtuse, so it looks like that's isosceles obtuse, technically. The big red triangle up here, I don't know that this is a right angle. Let's just call it acute. So then that would have been scalene acute. And down here, because this was equilateral, remember that that's automatically going to be equiangular as well. So all triangles do have two names, but this instructions only really ask for the side name. All right, let's keep moving on. Now we may need a calculator to figure some other things out, but at first, let's just take a look at the instructions. It says to identify the triangle by its angle and side. So each of these triangles will need two names. So let's go across the bottom row. You'll do 9 through 11 on your own. But for number 12, I see that this is a 15-inch side, this is a 20-inch side, this is an 18-inch side. So I know that that's scalene. No sides congruent. Now this angle, this angle, and this angle, none of them do I know the measurements for, but they all look obviously acute. So I'm going to call this scalene acute. For number 13, I see the right angle there, so this is glaringly a right triangle. No sides are marked congruent, so no sides congruent is going to be scalene. So it looks like scalene acute, scalene right. Notice in 13 they didn't tell me anything about the sides, so they were all different by default. Over here they literally told me that they were different. Over here on number 14 I see 5 and 5. Nothing about this third side. So that's going to make this isosceles by side name. By angle name, I see an angle greater than 90, so that's going to be obtuse. You're going to do 9, 10, and 11 on your own. Okay, and this will be one of the things that I'll be checking in with you to see if you've grasped this concept. Don't forget, every triangle is going to have one angle name and one side name. Use your notes to determine which one is the most appropriate. Press pause and take care of that now. Now again, seeing is the toughest part. So I see right here that I have a 90-degree vertical angle. I see that I have a 120-degree angle here. I see a 60-degree angle here. If this is 120, then right here is a linear pair, so that must also be 60, because 60 plus 120 is 180. And now all three angles in a triangle add up to be 180, so if this angle is 60 and this angle is 60, then this one must be 60 as well. So I put that angle measure in there, but we're getting a little ahead of ourselves. Let's first see who's on the board here. First thing I see is triangle UQR. So UQR is going to be U to Q to R back to U. And I see that that is marked with 2 tick marks. And they want me to give an angle name and a side name. So by side name, that is isosceles. And because I have the 120-degree angle, that is obtuse. The next one I'd like to do is SRQ. So SRQ is SRQ right here. Well, we got the right angle, so that's definitely going to be, oops, I'm in the wrong spot. A quick correction there. So we definitely know it's right. I don't know anything about the side lengths, So I guess I'm just going to say that that's scalene. And then we'll skip down to say PQT. So P to Q to T. Again, don't know anything about the side lengths, but I do know that this is a right angle right here because they're vertical. So I suppose that that's also going to be right for an angle name and scalene for a side name. How about one more for good measure? So how about PRT, one more red one. So P to R to T. I'm going to clean this up a little bit. I've cleaned this up a little bit, but because this was 60 and this was 60 right here, so because those two are 60, that would have made triangle TQU equilateral. And if these three sides are all the same, well, this is 8 meters and this is 8 meters, I guess that means that's 8 meters, which makes this whole thing here 16 meters. And if this is 16 meters, then I guess TR is the same as TP, which would make this PRT, triangle PRT, isosceles, right? Because these two sides here are the same, and two sides the same would mean isosceles. Now, if you were to take an index card and pop it into this angle right here, you're going to notice that this angle right here is definitely larger than a right angle. So I think this is going to be isosceles obtuse. Now I just gave away this little triangle in here. We talked about that being 60, 60, 60, and I think that helps you out with these, one of these other two answers. So why don't you go ahead and fill those out on your own and make those another part of things that you want to check in with me after the video. Now we're going to get into the algebra a little bit here, and it seems that this triangle ABC is equilateral, which means that all three sides are congruent, which means that BC is congruent to AB, and segment AB is also congruent to segment AC. Now, they want me to solve for both X and Y here. So let's go ahead and start with X. X refers to this side here, which is BC. That's 3X plus 1. And who's BC the same as? AB. AB is 49. So if they're congruent, set them equal. You can go ahead and finish out the algebra and give me an X equals. And then we will have solved for X. On the AC side of things, I have 18Y minus 41 is AC. So I have 18y minus 41, and what's that equal to? Well, since they're all equal to each other, this is also equal to 49. And this is my poor attempt at a y right here. So again, simple enough, you should be able to solve for y. And that wraps up number 1. On number 2 here, it said that this is an equilateral triangle. They want us to find x, and then they want us to find the measure of each side. So when I look at each side, they all involve x. Now if it's equilateral, don't I know that this side, and this side are all alike? So if they're congruent, set the terms equal. So 10x minus 6 equals 7x plus 18. Once you solve for x, you have the ability to get the length of this side, and this side by substituting x into those expressions. So you should have, for a final answer, x equals something, and then st equals a value, rt equals a value, and rs equals a value. Now, you should be asking, well, could I have had another algebra statement that started with 12x minus 22 equals 7x plus 18? Of course. And if you solve that, you're going to get the same value of x as you did here. So these two x's are going to be the same. So you don't need to keep solving all these different equations. Just pick one and solve. Once you get the value of x, substitute it back into the expressions for all three to get the measure of each side. So you're going to have to finish numbers 1 and 2, and then, of course, at the end of the video, check in with me. Press pause and solve those now. Feel free to come and ask questions if you're stuck. For this question, it says, find the measures of the sides of the triangle and then classify it by side name. Okay, so to find the measure, given 3 points, we're going to use our old friend, the distance formula. So I have the distance formula down here. Distance equals the square root of the difference of the x values squared plus the difference of the y values squared. Not possible to have a negative answer. To drive home that point, I got my no negative sign down here. Now, it's talking about triangle JKL, so I just want to draw a triangle JKL. It doesn't matter where you put the letters, as long as they go in the same order they mentioned. There's my triangle JKL, and I'm going to have 1, 2, 3 sides to get the length of. So I'm going to have length JK is equal to the square root, all that stuff. And then I'm going to have the length of KL, right, my second side, equal to the square root of a bunch of stuff. And then I'm going to have JL, and that's going to be the square root of a bunch of stuff. Now notice what I did. I set up the distance formula 3 times. And I'm going to just work nice and slow and start putting in the information. So first, for JK, I'm going to have x2 minus x1, so that's negative 9 minus a negative 7, all squared. And then I have my 1 minus my negative 7. And when I finish that out, what's my final answer? Take a moment, press pause, and you calculate it out. You should get the square root of 68. And we're just going to stop there because all we're really interested in doing is classifying by side length. So I don't need to know the exact length of the sides, in terms of a decimal. I just need to know who's alike and who's not alike. Now let's move on to KL. KL, I haven't labeled it yet, so I'm going to call this x1, y1, because I already have this labeled as x2, y2. So for the difference of my x's, I'm going to have negative 9 minus 1, minus a negative 1, I'm sorry. And then I'm going to have y is a 1 minus a negative 1. And then that's going to come out to, let's take a moment, press pause, and calculate it out. And lo and behold, that is also the square root of 68. Now what about JL? So I got J and L. So I have these both labeled as x1 and y1, x1, y1. Just pick one to recall it 2. Let's call this group 2. So then that's going to be a negative 1 minus a negative 7, and then a negative 1 again for the y, minus a negative 7 again. And that's going to give us over here a negative, or rather a positive 6. This is a positive 6, so 36 and 36 is going to be the square root of 72. So I have 2 sides alike. I guess this is an isosceles triangle. So square root of 72, square root of 68, square root of 68. Type of triangle, isosceles. Here's a little neater version for you in case you wanted a cleaner copy. All right, that was 21. Now you're going to try 22 on your own and check in with me at the end of the video. Correction, make that 23. So go ahead, press pause now, and if you need any help with this, if you're not sure what's going on, feel free to check in right now with me for some questions. If you don't have any, just complete this and continue moving on. Alright, so we're just about done. This is very similar to the triangles with the pictures, except you don't have a picture. So what could you do? You could draw one in. You have triangle ABC, so draw a triangle ABC. Alright, and what is it? It's an isosceles triangle, so I know I have 2 sides alike. Who are alike? Segment AB and segment BC. Segment AB and segment BC. Mark up your triangle. Now I know AB is 3x plus 41, so that's 3x plus 41. And down there, BC is 8x minus 54, so 8x minus 54. And now I have the same as before. It says find the value of x and then the measure of each side. Of course, I have AC is 12x minus 103. Who do I set equal to each other? Well, this side and this side are marked congruent. So if they're congruent, what do? You betcha, set the terms equal. 3x plus 41 is equal to 8x minus 54. And why? Because they're congruent, so I set the terms equal. Now you can figure out an answer for x. Once you get the value for x, of course, substitute into each variable expression and get the lengths. Your final answer should look like AB equals some number, BC equals some number, and AC equals some number. So a value for x, and then these three answers. Of course, AB and BC should be the same number. Don't just fill it in twice, make sure it actually works, because then you know your algebra is correct. Press pause and complete that one. On number 6, triangle PQR is equilateral. So I draw myself an equilateral triangle, PQR. If it's equilateral, all three sides are alike. PQ is 18x plus 1, so that's 18x plus 1. QR is 24x minus 17, so that's 24x minus 17. And PR is 15x plus 10. So I have a well-labeled diagram. Find x, of course, and find the measure of each side. Now, any two of these will work. So I'm going to just pick the ones with positives in it to make my world easier. 18x plus 1, so an 18x plus 1, equals 15x plus 10. Solve for x, then of course you guessed it, substitute the variable into all three variable expressions and get a length for PQ, QR, and PR. Now of course, if you'd like, you could set up an alternative version. 18x plus 1 is certainly equal to 24x minus 17, or 24x minus 17 is equal to 15x plus 10. The world is your oyster on this problem. Why? Because all three sides are alike. So whatever two you want to use, use. But that's all you got to do is just do it one time. As soon as you get the value of x, you're all set. Complete number 6. Finish up with your notes. Check in with me on all the problems. We'll go over it. And then you'll be on your way to the homework. Thanks for listening. Hope this was helpful.